Hey everybody, welcome to Chapter 6. Today is 6.1, Rational Exponents, and actually this is going to be day 1 of Rational Exponents, and today's target is to evaluate nth roots. Now if you haven't done so already, the thing I need you to do in this lesson first is I need you to go find what is above this, and I want you to go find your exponent table and fill that in. Alright, so go find your exponent table and fill in your exponent table if you haven't already before you get this lesson going. Thank you. To start off today, we're going to do these two very simple questions. And 5 squared is exactly what you think. It is 25. No shocker there. And 6 squared is in fact 36. All right, and that's easy. All right, if I had, maybe I did 4 to the third, okay, that would equal then 64. All right, because I do 4 times 4 times 4. Okay, but that's easy. That's what we've known. What I want to take a look at today is what if I had the other way? What if I did 25? What if I had that to the 1/2 power? Or what if I had 36 to the 1/2 power? Okay, well that doesn't make sense that would equal 12.5 because that's what 25 multiplied by 1/2 would be. And that's not what we're doing here. We have an exponent of 1/2. So it's not 12.5. All right, it's very simple. If you think about it, it's going to be 5. So what is 36 to the 1/2? That will be 6. All right, so what have we figured out is that what is the exponent of 1/2 going to be? Well, that is the good question. So why is that the answer? Well, we figured out that that's the same thing you get if you take the square root of 36, you would get 6. So why is 1/2 as an exponent going to do the same thing as a square root? All right, well, let's take a look at a few examples. All right, so first thing, let's just imagine, well, what happens when I do x to the third and I take that to the fourth? Well, based on our properties of exponents, so remember way back when in section 5.1, day 1, we did the properties of exponents. All right, so we want to remember that lesson and go back and look at your notes and find the properties of exponents. We discovered that 3x to the third to the fourth would actually become x to the 12th. All right, because you'd multiply the 3 and the 4. All right, let me get rid of this part right here. We don't need to see that anymore. So why is x, I'm highlighting, why is x to the 1/2, the same as the square root of x? Well, what happens if I had x to the second and I raise that to the 1/2 power? Well, same thing there. On this one here, I multiplied my exponents. So here again, based on the power of a power, I will multiply my exponents. And 2 times 1/2 is just 1, which is x to the first, or just x. All right, and that's the same concept. If I had x squared and I took the square root, that is going to become then just x, which is the same thing as x to the first. So that's how the square root is the same as an exponent of 1/2. So again, a 1/2 exponent doesn't mean we are going to take half the base. It means we're going to take the square root of the base. Again, don't forget about the properties of exponents we're going to use again, so that lesson 5.1, day 1. And I think in your blank notes, I have those properties there as well. So let's look more at rational exponents, okay? Rational, indicating kind of like the word fraction. A rational number is, remember, any number that is either terminating as a decimal or repeating as a decimal, which could mean it's just basically a rational number is any kind of fraction. So today we're going to look at fractional exponents, fractional exponents. Okay, so if I had a to the m over n, so you can see there's my fraction, m over n, that is going to become notice I have n here and m there. All right? We already know what m is. M is just simply called an exponent. All right? Well, what is n? N's right there. All right, you can't see green. N is right there. N was the denominator of the fraction, whereas m was the numerator of the fraction. So the numerator will become the exponent, and the denominator becomes right here. All right, now I know you're familiar with this symbol. You call it a square root. All right, which means that really there's a 2 right there. That is called the index. All right, and the index of a radical changes. All right, now we usually don't have a number right there, and that means square root. But I could have an index of 3, and then that would mean cube root. If I had a 4 with a radical, that would be called just simply the 4th root. All right, there are no fancy names after square root and cube root. You could call it the 2nd root, you can call it the 3rd root, then it's this the 4th root, the 5th root, the 6th root, the 7th root. All right, and the table that you should have made for today is going to be important to help you use the indexes. All right, you made a list of powers that are x to the 5th. Well, everything in that column is a perfect 5th root. All right, like 2 to the 5th was 32. So if I take the 5th root of 32, that's just going to equal 2. And hopefully you can see that on your chart. Okay, so again, if I have a number, the numerator is the exponent. Numerator becomes the exponent. The denominator becomes the index of a radical, okay? So let's take a look at a one that'll work. And it's called 27 to the 2/3 power, okay? So the way you would write that, oh, by the way, the way you say this right here, all right, the way you say this right there is you would call it the nth root of a, all right, in that case, and then to the m power would be the value there. So here, this is 27 to the 2/3 power. So again, let's take a look here. The denominator becomes the index of the radical. So there's my index there. The numerator will become the exponent out there, and then the base is 27. Now, where do you put the 2? All right, the 2 actually can go outside like this, or you could write it as the cube root of 27 to the 2nd. The 2 can go inside. So if you have 2 ways to do that, you want to pick whichever one is easiest. So every rational exponent has 2 ways to write it. You can write it with the exponent outside the radical or the exponent inside the radical. How do you know which to do? Which is easiest? Can I take the cube root of 27? All right, because if I take the cube root of 27, that's going to make my number smaller. And then squaring that number is a smaller number to square. But if I square 27 first, that's going to be a bigger number. So can I take the cube root of 27? Yes. So then do that first. So if you look at your exponent chart, look in the x to the 3rd column, and look for 27, and notice if you go over to where x is, you get a 3, all right? And so then that becomes 3, all right, because the cube root of 27 was 3, and now to the 2nd power, which would become 9, okay? So in this case, we wanted to do it that way up there, all right? When would you do it the other way? Well, let's take a look at another example. What if I had, say, a problem that was like 9 to the 2/3? All right, now be careful on this one. Again, the denominator becomes the index. The denominator, that's a 3. That's a 3 right there. So I have a 3 cube root Now, be careful. Can I take the cube root of 9? No, you cannot take the cube root of 9. If you look down this x to the third column in your table, notice you don't have a 9 in that column. I could take the square root of 9, not the cube root, which means I would want to take and put the 2 right there. And so 9 squared is 81. And I take the cube root of 81. Now look in your x to the third column again. Do you have 81 in that column? And the answer is no, then that's the final answer. That's as simple as it gets. Okay? So let's practice that a little more. All right, so all I want you to do in these examples is just use the other form. So right here, this is called exponent form. Notice I have an exponent. Down here, these are currently called radical form. Notice it has a radical in it. All right, so what form are you in? I'm currently in this one. I am currently in exponent form. I want to write it in radical form. So if I say radical form, that means write your answer with a radical. So that is going to become the 4th root of 5 to the 5th. Okay, again, the 5 could be outside or the 5 could be inside the radical. In this case, I don't want you to simplify right now. Just simply rewrite it in the other form. This one would be, part B would be the 7th root of x to the 3rd. Okay, or it could be the 7th root of x, that's a 7, root of x to the 3rd. All right, either one of these, this is correct and this is correct. Either one of those answers will be accepted. Okay, for right now, it's if x is known, then you'd want to do that. So like if x was a number to the 3rd, well, if x was 1, you could do it. The 7th root of 1 would be 1. Then 1 to the 3rd is 1. If x happened to be 128, that's what 2 to the 7th is, then I could take that. The 7th root of 128 is 2, to the 3rd power would be then 8. All right, moving on to the last one, part C. That would be, remember the denominator here is 2. So for a square root, we actually don't write a number out there, and then to be 3 to the 3rd. So you could simplify 3 to the 3rd, but for right now, let's just wait on that and just leave it there. Okay, so again, if you have a square root, you don't put the number out in front, so don't forget about that there. Okay, let's move on down to the bottom one. Now we want to write an exponential form, so we want to go in the other direction. So now that's going to become, remember, this is the denominator, this is the numerator. So that's going to be 4 to the 5/3 power. Now make sure your exponent is smaller than the base. You don't want to make it 4 to the 5/3. That looks like a mixed number, and that looks like 4 and 5/3. We want not that. We want to have 4 to the 5/3. All right, part E. All right, there's an exponent of 1 right there. So remember, that's the numerator. This is the denominator. So this would become x to the 1/7. Right, notice the 1/7 is all up higher. That's good. Again, this was good. I'm going to change my color. Let's look at F. Now, F will throw people for a loop. All right, notice people are going to want to write, here's the numerator. Where's the denominator? All right, where is it? So this clearly shouldn't be x to the 5th, because the square root of x to the 5th isn't x to the 5th. That should be, I didn't write a good 5 there. That should be x to the 5/2, don't forget. Okay, so the 5/2 there. So that's just writing it in the other form. This will be the first kind of type of homework questions you'll see. Now, I just want you to see this. Here's another example you're going to see today. The book kind of doesn't give you a very good description of these kind of problems, so I want to show you them. It asks for the nth root. Okay, so just so you know what that means, I'm looking for is that we are going to do, so notice they give you n equals 4 and a equals 625. That is going to become, you're using this formula, nth root of a. So which means n, right there, that's the index. N is the index, right? And a is going to be then the base. Okay, just to make it easy, simple terms. So the way I'm going to write that is I use a radical. and the index is 4, and the base is 625. So then the question is, can you take the fourth root of 625? So look in your exponent table, look at the x to the fourth column, go down until you see 625, then move over, and what number is that lining up with? That's going to be 5. But this is an even index right here. 4 is an even index, which means like a square root, and we're trying to find roots, we're trying to find solutions, my answer would be plus or minus 5 in that case. Because positive 5, if I did 5, 5, 5, and 5, multiply those together, those are 5s, not s's, sorry, that would be positive 625. But if I had negative 5, negative 5, negative 5, and negative 5, that's also going to be a positive 625. So don't forget about when you find roots, you're looking for all answers. Okay? Now the next question is where your index is 5 and your base is negative 32. All right, so I'm looking at the root, but my index is 5, so that's called the fifth root of negative 32. So can I take the fifth root of a negative number? All right, well, just like up here I had plus or minus. Notice if I had a fourth root, I'd have a positive number to do a fourth root, right? Because there's no answer that's going to get me, no number multiplied by itself 4 times will get me a negative. All right, now we have I, but I is only in square roots, not in fourth roots. So here's the fifth root. Well, let's look down our x to the fifth column. All right, now obviously those numbers are all positive, and you see 32 right there. And if you go over to the left, you see that's compared to x equals 2. Well, if I had the fifth root of positive 32, that answer would be 2, because 2 times 2 times 2 times 2 times 2 would be positive 32. What if I had negative, 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 and negative? Now that's 5 negatives, which would actually become a negative 32. So I can solve this problem. I can take the negative. If it is an odd index, you can do negative. So that answer would be then negative 2 is the only root in that problem. Up here, you had 2 roots in that problem. Okay? So just so you can see that, this one right up here would be read as the fourth root of 625. Number 2 is really asking to find the fifth root of negative 32. So then you can see it in writing, and you can see it in symbolic form. Now, what would you do if you could try this on the calculator? Okay, we don't have any number that's 20,000 in the, we're trying to do the fourth root right here. So in the fourth root, all right, if you look at the x to the fourth column, there is no number that's above 1,000 there. So 20,000 is higher than that. So in this case, we can use our calculator. So let's see if you know how to use the calculator on this. So try these two. Can you type the fourth root of 20,736 into the calculator? All right, try that for yourself real quick. So the way you would type that in is you would first find the math button on your graphing calculator. When you push math, if you look down at option number 5, you get that x to the root. If you touch that button, you notice that depending on your calculator, if you have an 84 and a newer 84, you have a flashing cursor right there where you can type in the 4, and then you'd have the radical, and then inside here, all right, so if you type 4, then you got an arrow inside of the radical, and then you can type in the 2736 and hit enter, and you would find that that is equal to 12. Okay, so that's math option 5. If you have an older calculator or an 83, what you'd want to do, all right, so if you have an 83 calculator, you'd want to type in 4 first, then push the math button, then hit number 5, and you'll look like this. It'll say 4x root, and that means the 4 is taking the place of the x, and then type in the 2736, and probably a parenthesis there, close that parenthesis to equal 12 on the calculator. Okay. Another option here is you could do parentheses 2736 and then do a caret and then use it as to the 1/4 power, and that also will equal 12. So you got two options there. You can use the math button as an option, or you can use exponents if you remember the rational exponents there. Okay. To do the second one here, to do this one, I would do again math option number 5, and I would do the 9th root and then just type in parentheses -230, right? And if you type that in, you end up getting 1.829984, and maybe some more decimals, but that's just how you can use the calculator. So if they ask you to use the calculator on the homework assignment, you can use it effectively. Okay, so here we're talking about some examples on using the properties of exponents that we did from chapter 5, section 1, day 1. All right, and notice here I have the same base. So if I have the same base, I can add the exponents. So if I add fractions, remember to add fractions, common denominator, so 1/2 plus 3/2. All right, that would get me 4/2, so that's going to be 5 to the 4/2 power. Well, 4 divided by 2 is 2, so it just becomes 5 squared, and that is 25. Okay, so that's adding the exponents. You got to add fractions, common denominator. Number 2 here, now I have power of a power, so I'm going to multiply my fractions. So I would take 5/2 multiplied by 2 over 1. Okay, and then I can multiply straight across, or I can cross cancel there. Notice I'd get just simply 5. Well, or I would get 10 over 2 if I multiply straight across, which is still just 5. So I end up with just 3 to the 5th power, and 3 to the 5th power on the calculator or on your exponent chart, which is easier. The exponent chart is there because it's even easier than typing things into the calculator, is 243. Now I'm going to do 36 to the -1/2. And remember, I haven't asked this question in a long time, but how do you make a negative exponent positive? Remember, the answer is you take the reciprocal of the base. So it's going to be 1 over 36 to the +1/2 now. Remember, a 1/2 power, that's like having the same thing as the square root of 1 over 36. And then that would simply become the square root of 1 over the square root of 36, which is just then 1/6. Right? On 5, now we are dividing, so we subtract our exponent. So if I subtract, it'd be 5/2 minus 1/2, which would then be 4/2. I did this easy for you. So then that's going to become 4 to the 2nd power, which is then just 16. Okay? And very similar on 6 is kind of the same way I ended up doing number 3, only it's not a negative exponent, where if I have something to 1/3, so I could do that as a cube root, or I could take it as it'd be 27 to the 1/3 over 64 to the 1/3. All right, and if you like that, that just becomes 3 over 4. If you're not a fan of the way I did that problem, then you could have changed it to the cube root, sorry, that's a 3, of 27 over 64, which would then become the cube root of 27 divided by the cube root of 64. If you use your exponent chart again, the cube root of each of those would just be 3 over 4 is your final answer. So here's your assignment here, and it says right here without calculator, And that's the exception of there's one question, it's on 35. I do ask you to use the calculator. So on 35, use the calculator. On the other ones, don't use the calculator and practice using your exponent chart. Good luck and thank you.